is 2017. All right, so usual thing, plugging in is 1, left hand side equal to right hand side. N equal to K, wherever you have N, you just put K. Now prove, assume true. Yeah, well, you can use the all right, so she going to the normal steps. All right. Now she's going to write this statement that represents the K plus 1 term. Right, remember, when you reach here, this is always the summation of R going from 1 to K plus a K plus 1 2 all the time. Plus K plus 1 2. Okay? This is always what? This is always here. Okay? Right? So we should come with a little QED there. Amanda, you guys ready? And this K plus 1 term is always what? This K plus 1 is always taking off R and putting K plus 1. She did that here, right? Now look at this. You have 2 fractions, but your answer have 1 fraction. Put K plus 1 over K plus 1. Should we stop here now? We don't know. So I'm thinking about that. Let's see. Right, Shibish, what to do here? Otherwise, so find the LCM, right? Find the LCM, we'll go. Right, expand at the top and then factorize it. Up, right? Where you get lost? I get lost trying to fractions. I didn't know. They know what to do. You had no clue at all. Well, look at your hands. Look at what you're trying to prove. It has 1 fraction, right? Yeah. So what you can do is what? LCM, right? Yeah, how do I try it? All right. So that's the way you work it out. Up until once you all go over this, you should reach at least here. Right? Let's just say you reach here and you don't get this part, but you do a little reaction and write this, and you write the last line, was 8 marks, that's 6 marks. right? Two marks for this here. Okay. So make sure you understand how to reach here properly. Try it still. Try and see some factorizations easy. So what she did when she reached here, she found the LCM, right? And did it with the numerator, expand it out, and then factorize. This cancel and you end up with this. The last type is inequalities. You have to prove PMI, but instead of a summation like this or divisibility, what you have is an inequality sign, less than or more than. Right? Those never came before, so I'm only giving it two. I'm giving you, I will do the hard example, and I'll give you an easy one to try. All right. So let's see if we could prove by induction that 3n plus 1 is less than n plus 1 all squared for n is more than or equal to 2. All right. So here's what we're going to try. We have to prove this. Same steps, but it's a little more challenging working with the inequality. Right? This one I'm doing here is a little bit harder, so I'll give you an easier one, right? So let's start. Notice here, what does it say here? Can I use n as 1? No. If you use n as 1 in here, it will not work out. You will get 4 is less than 4. That's not correct, right? So that's why they said n is equal to 2. So you're starting here. N is 2, right? N is 2, you'll get 3 by 2 plus 1 is less than 2 plus 1 squared. This is 6 plus 1 is 7, is less than 9, which is true. Okay, next. You want to assume true for n equal to k. So everywhere you have n, put k, right? So 3 to the k is less than k plus 1 squared, right? For all k is more than or equal to 2. Next step is what? So you want to show it holds for n equal to. So again, I'm going to take up n and I am going to write k plus 1. Right? This is k plus 1 plus 1 squared. So technically, I have to prove 3 by k is 3k. 3 by 1 is 3 plus 1 is 4. It's less than k plus 2 all squared. So this is what I have to try to prove. So in the inequality type, I have to try to prove this here. 3k plus 4 is less than k plus 2 squared. Right? The method I am going to use is I am going to start with what I know. Right? All I know is this. Since 3 to the k is less than k plus 1 squared, right? That's all I know. So I'm starting with the statement that I know, right? So since we know this. All right, so I'm starting here. I have to go from here to here. Oh, I'll leave a plus 1. Yeah. Right, yeah. So I need to go from here to this. What do we do? Right? We have to find a way to convert this to 3k plus 4 and convert this to k plus 2. Right? Here we can try. If we were to add 3 here and add 3 here, would I change inequality? Would I change the sign or anything? If I add 3 here and add 3 here? No, right? So what you'll get here? What you'll get here? K squared plus 2k plus 3. This is 3k plus 4 is less than k squared plus 2k plus 4. Can I factorize this?
Yeah.
And you'll get what? 3k plus 4 is less than k plus. Someone wrong there? I look into that. All right. I feel I write something wrong in the beginning. I'll check back where I get it from, right? But watch this here. But this is the principle. You start with what you know, right? You start with what you know, and then you want to get this, right? So yeah, you have to make an addition or subtraction or multiplication that would allow you to get your answer, right? I suspect I write something wrong there. But that's the principle behind it. We'll write this one down. Try this one here instead. Yeah, it's all natural, so you can start with one. One should do. Right, so usual thing. Check when n is 1. What you'll get here? You'll get 2 to the 1 is more than 1. Is that true, Brittany? Is that true? 2 to the 1 is more than 1, right? What's the next line? Assume true for n equal to k. So what to do? Right, take off the n and put k. Right, here is now what? 2 to the k plus 1 is more than. Right, good. So what do we know? We know that 2 to the k is more than k. Right. Question. How are we going to get? Oh, by the way, this is for, right, for all k and stuff, right? So what do? You want to get 2 to the k plus 1, right? So one of the options is what? Right? Multiply by k by 2. So let's try to multiply by 2 and see what will happen. You'll get 2 to the 1 by 2 to the k is more than 2k. That's okay? 2 to the 1 plus by 2 to the k is what? 2 to the is more than 2k is really what? K plus k, right? Is that the answer? What will you do? What do we know about k? A natural number, right? So if k is a natural number, it means that k will always be more than 1. Correct? And there's a more than sign. A more than sign. So here's my question. Since k is more than 1, right? If I were to take off k and put 1, will this value become more than this, or will it still less than this? K is more than 1, right? So this k value here is always going to be more than 1. So if I take a value that is technically smaller than k, which is 1, less than, then this here will always be smaller than this. That makes sense? Yeah. Right? Let's just say 5 is less than 2 plus 2. Right? If I choose a number here that's always smaller than 2, and this will always be out with this here. Yeah. So here what I did, I choose a value for k that's smaller than this, which is 1. So I'll never change it. This doesn't change. And once you can prove that, good to go. Right? Yeah, but this intuitive step what hard. Right? You have to sit down and figure out, okay, what do I do here? I reach up to here. What do I do to make this look like that? Right? Obviously, you can't just rub off k and put 1, right? It must have a reason why you take off the k and put 1. And the reason is k is more than 1. So if I choose a value smaller than 1 to represent k, then this inequality here will never change. Copy down. Oh, by the way, you have to write the last line, right? Since it holds for n equal to 1, n equal to k, and n equal to k plus 1, it holds for all, right? Try that there. try 2 to the n is more than n squared minus 1. N is more than or equal to 4, right? Well, let's watch one more thing, right? You might need this help to figure this one out as well. Watch this here. Instead of doing this, right, we could also do this. Instead of saying 2 to the k is more than k, you want to prove this. Here we could say so 2 to the k plus 1 is equal to 2 by 2 to the k. Correct? And these two things equal, right? And since 2 to the k is more than k, since this is more than k, then what would happen if I take off 2 to the k and write k? Would this still be equal? No. Correct? Oh, sorry. Yeah, see how they get lost. So this is equal to this, right? I want to take this off. If I take this off and I put k, what would happen to this sign here? To what? Less than? You sure? So think about this. This value is bigger than this value. Right? So I'm taking off that value and I'm putting something that's smaller than. Something bigger than. Right? This is bigger than this. Correct? This is bigger than this. So if I take off this and I put a value that is smaller to replace it, then this whole thing becomes smaller, right? So it means that this will be larger than this. You're seeing that? So yeah, think about that as well. So suppose you are not seeing to multiply by 2, you could also do it like this. Then use the inequality, then write this, and of course, write 2 to the k plus k. Right? This is the next way that you can approach it. So take the left hand side and see what you can do. Right, so when n is 4, you'll get 2 to the 4 is more than. This is 16 is more than 15, which is true, right? N equal to k is 2 to the k is more than k squared minus 1. And n plus 1 will be 2 to the k plus 1 is more than k plus 1 squared, which I think is k plus 1 squared minus, which is the same as, when you expand this out, you get k squared plus 2k plus 1. So you'll get k squared plus 2k plus 1 minus 1. Just cancel out. So you're trying to prove that.